This is Scott from KIG. It's October 12th, 2016, and we're going to do a runoff video today of this Zarsky 7.5 ton air-cooled chiller. We have the upper cover, well, the upper covers and the lower covers off this unit. And the way the Zarsky's set up, we can leave them off for the duration of the test, which is kind of nice, just so we can show you some of the inner workings and controls and so forth of the chiller. But we do have all the bottom panels here, as well as this side panel right here also. So those are all the covers for this particular chiller. In this case here, I'm just going to start by turning it on, then talking while the unit's running, talking about a few more things, because it does have that open cover configuration, as opposed to having to do three or four different videos. So we already have power to this unit right now. There's basically a simple selector switch here. You have off mode, the white little tab points to off, then cooling cycle and pump only. When you turn on pump only, just the pump runs. When you turn on off, everything is off. And then cooling cycle, the pump is also always on. But you're only going to start cooling based on your set point and so forth. This is a brand new controller we just installed. So I'm going to turn it into the cooling cycle right now. And when you get that little surge in power, it takes a couple seconds for the controller just kind of reboot and do a little bit of a self-test. We've already set all the relevant settings inside the controller here. Right now we have the tank, we only have the tank like half full, full of 50% glycol, so we can chill down to about 30 degrees. This number down here tells you your set point, as indicated by the SP. The upper number tells you what the tank temperature is. And right now we're a little bit below the set point, but we're going to bring it down to 30. To do that, you press the circle or enter button here over on the right side once. That brings you to set point mode, 75. We're just going to press the down arrow. I overshot a little bit. So you can tell it's real time. The compressor already kicked in. We're starting to chill. So we're going to bring it down to 30. Enter, and it just defaults back to that screen. So my set point's 30, and we're starting to chill. So while we're down here, we have our centrifugal pump. This draws off of the tank, or suctions off the tank. This center of a pump is always the suction side of a pump, and it's discharging up here. This is your output. Right here, that's your output to your process. And this is your input. Now, important here is that we also have this line here. This is your bypass. So you already have a bypass. You don't have to pipe in your own bypass out here. Back out a little bit. And so if your flow is a little bit restricted on the coil heat exchangers, which we have over there, you can see one much taller than the other. Those are going to stack over each other. If that restricts the flow a little bit too much, you can crack this open. This is all the way closed. And then you might maybe crack it open a third of the way or so. What that does is that gives some additional flow back into the tank where the heat exchanger is, so we don't limit too much the amount of flow going over the heat exchanger, because there's a minimum amount of flow needed. Actually, while you're back here, you can see up above, that's the flow switch. That's the integrated flow switch for safety in the chiller. And now down below, this is called a Y strainer. That's basically a filter. Periodically, you should take this cap off here, and there's a little mesh screen there, and you check that for debris. The chiller has 1 1/4 inch NPT fittings, and it's going to ship out with just this bushing and this bushing here, which are 1 1/4 male NPT fittings. This is our equipment here just to set up a loop. You should put a shut-off here and a shut-off here prior to going out to your process piping to get to your two immersion coils. So you can see we're already down to 51 degrees, and this will overshoot a little bit, several degrees or a few degrees past that set point, just because of the inherent refrigeration and the amount of and the low load and the relatively low amount of fluid that's in the tank right now. This is your 7.5 horsepower Copeland compressor. After you do get initial power to the unit, it's a good idea to leave it under power, or before you turn it on, wait about an hour. This is a crankcase heater. This is always on. As long as there's power to the unit, even if you have the off button on, as long as there's power coming live into the chiller, this heater stays on all the time. That keeps the refrigerant from getting too cold in a cold startup condition. This here is a high pressure switch, and that works in conjunction also with this this fan switching VFD drive here to give you your low ambient feature. So unlike some other chillers, because this is designed to also be able to be outside in colder environments, and I think this is going to Indiana, which that is, the fan's not always going to be on all the time. You can see right now, or here right now, the compressor is running, but right now the fan is actually slowing down almost off. That fan will constantly be going on and off based on the high pressure readings it's seeing, and that's to help us for low ambient conditions. We have a freeze-stat in the unit. We'll preset that. The cover's not on right now. That's a safety device. We're going to preset that based on the fact that the customer is going to run to 30 Fahrenheit. You'll hear that click, by the way, and the fan just turned on. That'll be set at the appropriate temperature, based on the fact the customer should be running about 40% glycol, as related to a 30-degree Fahrenheit process temperature. So we have just our test cable coming in here for the incoming power. That comes into our main contactor here, where you see black, blue, and red, and then obviously a ground too. This customer says their three-phase power has a wild leg. You don't see that too often anymore. The main thing is you see this controller transformer here, and you got to look closely. There's two black wires. That's a single-phase transformer. There's two black wires to get your 230 or 208 volt single phase, just two lines off your main incoming power. There's one right here, okay, and then the other one is right here. In this case, those two wires go to the leftmost and the rightmost of these three main incoming power connections. You need to make sure that whatever two lines these are connected to are not that wild leg. Otherwise you start blowing fuses or possibly transformers, that controller transformer. That's the main thing. And double check with your electrician too. They'll basically say the same thing. Nothing else in here. These terminal blocks here, or this terminal block here, that's for if you have the remote start-stop module. It is something you can order from Cold Shot Chillers if you'd like. Then you just have your main fan pump relay and your main contactor capacitor for your fan motor in here too. This is all covered by that cover right there, which, as we mentioned to the customer, did get repainted, and the prior weird logos from the yogurt shop it was at were removed. When you do first start up the chiller, you can connect your three-phase power. It is three-phase, so it's rotation specific. In this case here, it's easy. You can look at the back of the pump and make sure you have correct rotation. So you can see right here is an arrow that says rotation. So after you get your three-phase power connected, first thing you do is you get a helper, or you can actually probably reach here if you're doing it by yourself, and you just bump the pump on and off. I'm going to digress for a second. So you got about 2 degrees below the set point, and you just heard the compressor shut off, so that's normal. So there's a little bit of, we'll start, because we have little volume in there in the tank, it's going to start increasing fairly quickly back up to the a couple degrees over the set point and start chilling again. But once there's a lot more volume in the system, you're not going to see the temperature going up and down like that. The temperature, by the way, is the tank temperature. So getting back to the pump here, you saw the rotation arrow. When you bump the pump, you want to have somebody back here with a flashlight, and you just bump it really quick to make sure you have that right pump rotation. If you don't, you change any 2 legs of an incoming 3-phase power, and then you do that, or if you have to do that, make sure again about the wild leg going to the controller transformer. We have an insulated stainless tank here. You have a drain. Again, this unit has the cover option, so all the covers will ship out with all the covers on all 3 sides. If it was us during startup, we just have the covers off for the first day or two, so everything's hunky-dory. You know, check the tank level a couple times. It does have a you do have a fill here, and you do also have this sight glass for the tank level. In this case here, the way it's set up, we just put in some high concentration glycol. We probably have it like a 5th full just for this particular test. But you bring it right up to the top. The lighting's not super great here, but you have a stainless cover. Tough to see in there, but the brazed plate exchanger does sit in the bath of the glycol, which is a preferred way to do it as far as insulation qualities, and also in the unlikely event you run too low of a glycol solution, that helps prevent quick freeze-ups inside. So we're stabilized at right about 30 right now. It'll take a while for it to get back up with no load before the chiller turns on again. These are the coils. They look a little bit squished when they're just resting here, but these will ship out with the chiller. You got 1/2-inch NPT fittings, male threads here, and we'll have a little clamp to hold these together here, but basically this one will sit on top of the taller one, and you probably want to just clamp them all together and then make your connections. And you're going to have your outflow from here. You're going to have it go to a T, and then your output flare out to the 2 inputs of that, and similar on your return. Might be a good idea to put a pressure gauge or 2 before the inlet and the outlet of the heat exchangers here, just to monitor, record and monitor and compare over time for what gives you the best heat transfer, because you'll be able to adjust the amount of flow that's going into those exchangers by your shutoffs here, combined with your bypass there. By tweaking and playing with those and measuring how quickly you're bringing down your tank with those 2 immersion coils, and that's 200 feet of 1/2-inch stainless steel, that may help you dial in your process. So we're going to put the covers back on and get this baby ready to ship and post this video. Lastly, sorry, it's the cold shot chiller ACWC-090 EOR serial number M060710-1. That 10 means it's a 2010 2-horsepower pump. That's nice. R410 refrigerant. This is a well-tested unit with a brand new controller, and it's ready to go. Scott from KIG. Our website's kigsales.com. Thank you.